Okay, welcome back to Dynamics ECS 429. We are in week 10. It is 3rd January 2022. Happy New Year to all of my students. And today is now 11:15 a.m. So today we are going to start our class. Can you see my screen, guys?
Yes.
Yes. Okay, wait. Where is my... Okay. Okay. All right. So for today's class, we are going to go into topic rigid body. Okay. But however, what we're going to do is we're going to learn on work and energy method. Okay. Now, if I open back our... Sorry. Alamak, tu nampak pula siapa yang I marking ni kan. Lesson plan. Okay, this is our lesson plan. So we are now in week 10. So we in week 10, we are going to learn about work energy method and impulse and momentum method. You have learned this previously for particles. However, now we're going to focus on rigid body. It will be something very similar. However, for topic rigid body, there is a rotation involved. Yeah? So what is the learning outcome? For this course for week 10, we want to solve the plane motion of rigid body of systems of rigid body using the method of work and energy. And we also want to solve the plane motion of rigid body of system using the method of impulse and momentum. Okay, so basically for today's class, we will not have time to do impulse, but we will do on work and energy. Okay, all right. So we're going to focus on work energy. Okay, so this is our learning outcome. Okay, now, so work and energy. So basically for today's class, our objective here is we want to develop a formulation of the kinetic energy of a body and define the various ways a force and a couple moment work. Okay, how a force, the forces and couple moment work. Okay, so couple moment is something new that I'm mentioning in class. Previously, we don't have moments, so we're gonna have couple moments. That does work. Okay, because couple moments cause apa cause the rigid body to have work involved. Okay. And what we're going to do is we're going to apply the principle of work and energy. Do you remember what is the principle of work energy? What is the formula? T1 plus work
Yes.
T2. Okay, so you remember that. So basically, we're going to apply the principle of work and energy to solve a rigid body planar kinetic problems. Okay, kinetics. This is already topic kinetics. Okay, and what we're going to do is we're going to solve normal things that we learn in work energy, which is force, velocity, and one more. What is it? What is it? Is it displacement or time? Class, when we talk about work energy, force, velocity, and one more. What is it?
Time.
Hey, aduh. Siapa cakap time tu? Rasa macam nak cekik-cekik time tu. This is work and energy. What does work? When there is a displace. So what is it? Displacement. Siapa cakap time tu? Aduh, displacement. Time is for work and impulse. So when you do work and impulse, you will solve force, velocity, and time. But when you do work energy, you're going to solve force, velocity, and displacement. Please be clear on this. Okay, my dear, please don't do that to me. Dapat heart attack nanti kang. All right. Okay. Now, let's recap a little bit on what we learned about kinetic energy. If you remember, okay, so let's look at the kinetic energy. So kinetic energy formula is is what? 1/2 mv squared. You remember this formula? This is when we learn in topic particles. But now, because we are talking about rigid body, there is a rotation. There is a plus what? 1/2 I what? I moment of inertia multiply by omega squared. Are you okay, guys? You're very quiet. Are you actually focusing? What are you doing actually? Huh?
Focusing.
Focusing. Okay, tak apa. Focusing. All right. Okay, now. So let's recap back. Okay, so basically what type of motion that we can have is number one is translation. So when a rigid body of a mass m is subjected to rectilinear or curvilinear translation, when a translation due to rectilinear or curvilinear, because translation can happen in two ways. One is curvilinear, one is also rectilinear. Okay, what happens to the omega? This is the velocity. The Vg equals to V. Okay. So when a rigid body or a mass M, let's assume this bentuk kacang ni macam rigid body, is subjected to either rectilinear or curvilinear motion, the kinetic energy due to rotation, equals to 0. That's why the T is only 1/2 mv squared. Okay? Alright. This is for translation lah. Okay, alright. Ni kita nak recap balik And we also can have rotation about a fixed axis. Okay, so when a rigid body rotates about a fixed axis passing through point O, okay, the body will have both translation and rotation kinetic energy. Dia akan ada dua. So let's say this is your rigid body and this is your center G. Let's say this is your point O. So this one will be your radius RG, and you will also have velocity PG lah. So it will have both. So it means omega ada value. Okay, so when a rigid body rotates about a fixed axis passing through point O, the body has both. Dia ada translation and dia ada rotation kinetic energy. Okay, dia have both. So due to that, dia punya T apa? Formula dia. 1/2 mv squared. Another one is 1/2 I g omega squared. Okay, understand that Do you understand that, guys?
Boleh.
Okay, good. Okay, good. And then what we can do is what it means is the body's kinetic energy may also be formulated in this case. Okay, so in this case the velocity is equals to r omega. Okay, so what we can do is sometimes T equals to 1/2. We can have Ig plus mr squared omega squared. Okay, so if you have an example, rotation is about a fixed axis, this one you can simplify the formula and use this one. Okay, all right. Okay, next we also have an example that can happen due to general plane motion lah. Okay, for general plane motion is when a rigid body is subjected to plane motion. It means it has angular velocity. Okay, it means dia ada angular velocity. Ni ada Okay, tadi ada tak? Ada. Okay, direction ni kita buat sama lah. Tukar. Nampak? Consistent. Okay. So general plane motion is when the body is subjected to general plane motion. So what it does, it has angular velocity. Okay. And it has a mass center of velocity. VG, dia ada mass center of velocity juga. Okay. Therefore, the kinetic energy, what do you think? The kinetic energy sama lah. Okay, it is two things, the same thing. Okay. All right. Okay, so this is the examples lah that you must remember for kinetic energy. So what we're doing here is kinetic energy. Okay. Next is work. Okay. Do you remember last time on topic particles we learned about work? The work. Remember work of a force? Work ada from one point to second point. So there are many types of work. What is the first type? Remember? Work due to variable force. Remember? Ni kita dah learn
Yes.
masa particle sebelum ni kan. Work due to variable force. Okay, so it will be due to S lah. F cos theta ds. And then we also have work due to weight. Okay, so we're gonna do the same thing that we did previously. And then we have work due to spring. Ini more to what do you call revision, but I'm sure you remember all these things. Okay, and then we also have one more forces that does not do work. Okay, we also have sometimes forces that does not do work. For example, if you have a circular disc macam ni, okay, weight ni, it cannot do work because it's not, there is a platform atas ni. Platform dia ada apa? Dia ada normal force dengan ada ada frictional force kan. So it cannot do work. It cannot displace downwards. Those are examples lah. Why it cannot do work lah. Okay, all right. This one is an example for forces that does not do work. So, okay, now, so this is the concept that we're going to learn in topic work and energy. So this is basically recap. So if you understand this, then we can start and do a few questions together and try to solve the examples. Okay, oh, but there's one more thing. Work due to couple moment. Now, work due to couple moment. Okay, so work due to couple moment. This is something extra for you. Okay, so work due to couple moment. What happens is the moment will rotate due to a certain angle. So work due to couple moment, dia punya ni ialah, sorry. This is something extra untuk topik rigid body. So work due to couple moment is the integration of theta 1 to theta 2 m d theta. Okay. Alright. If the couple moment has a constant magnitude, you terus boleh buat macam ni lah. Okay. So this is the additional for, this is the something additional which we didn't have before this. Compared to particles, and the additional also that we don't have before this is yang ada formula yang ada IG ni lah, 1/2 IG omega squared. Before this we did particles, we only had 1/2 mv squared kan. So those are the additional things. Okay, all right. Okay, so if you're ready, we're gonna try to solve problems related to rigid body and work energy. Are you ready, guys?
Yes.
Okay. Okay. Silent this all question, eh? Copy this question and let's do it together. Okay, dah habis Salim bagi tahu ya. Oh, untuk yang bagi apa nota dekat Adam Bashar tu, just bagi nota chapter 3 onwards saja because apa kita punya test apa okay test to 40% chapter 4, 5, 6 project 20% chapter 3, 4, 5 5 okay. Nampak? Okay. Azim, bagi phone mama. Okay. Project is poster. Okay, dah habis salin bagi tahu? Dah ke? Lamanya salin? You all buat apa tu? Okay, dah. Okay, now. The 30 kilogram disc shown is pin supported at its center. So, dia pin supported at the center. Determine the angle through which it must rotate. Alhamdulillah. I pun tengah apa sesama ni. Okay, sorry Okay. Okay. Determine the angle. So, dia nak angle lah. Angle tu theta lah. It must rotate to attain an angular velocity of 2 radian per second. So, dia nak theta. Tapi dia nak theta dalam bentuk angle lah. Theta ni dalam bentuk radian kan. So, nanti daripada radian you kena tukar ke angle. Macam mana nak tukar ke radian angle? Bila you dapat radian nanti? Kali dengan? Berapa? 180? Okay, bagi 4. Okay, alright. So basically dia nak tahu what is the angle when dia rotate, angular velocity dia adalah 2 radian per second. Tapi ini angular velocity ni, is this angular velocity omega 1 ke omega 2? Sebab dia kata starting from rest. So bila dia starting from rest, omega 1 is equals to 0 lah. So this one must be omega 2. Okay. And it is acted upon a constant couple moment. So dia ada what is causing it to move, rotate is this moment lah. So kita dah ada what is causing it to do work is the moment lah. So what is causing for it to do work is the moment. Okay. And the spring is originally unstretched and is caught wraps around the rim. So spring ni dia wrap around ni lah. Dia wrap around ni lah. Circle macam tu lah. Okay. Alright. So now, first we know that this is topic kinetics. This is topic rigid body, and what we're going to do is we're going to use principle of work energy lah. So principle of work energy is T1 plus work equals to T2 lah. So what is T1? Now, since T1, when you look at this example, because it's T1 is kinetic energy, so since what is the formula involved? Is there any movement? Class, does this apa orang kata, does this spring move? This move, class? Class.
Yes.
Tak kan? Dia rotate saja kan? Dia only rotate kan dengan omega apa?
Yes.
2 radian per second. So due to that, our formula is 1/2 I omega squared. Okay. Now, because our is start from rest, so T1 will equal to? Because it start, huh?
0.
0. So we need to calculate T2 now. T2 ialah I omega squared. Now, what is our I? I is moment of inertia. Now, for this question, we have is a disk, right? So for I disk, what is the formula? There are two types. 1/2 mr squared and the other one is mk squared. Which one you want to use? Which one you want to use?
MR square.
Yes. Why? Because I disk mk squared only if they say there is radius of gyration. But in the question, there is no radius of gyration. So we only use formula I this formula. Okay. So can you calculate for me what is your IDs? So IDs, I ialah 1/2, mass is 30, your R is 0.2 square. So what is your I? Can you tell me, can you calculate for me what is your I? Mana calculate? 30 times 0.2 square. 0.6, betul tak?
Betul.
What is the unit? Saya perasan bila marking selalu student tinggal unit please don't do that Sekarang ni you get lah the mark, but later on if you leave, we might not give you marks nanti. So make sure you put the units or else you won't get marks. 0.6 times what is it? 2 lah, kan? Square. So that is kinetic energy. So what kinetic energy do you get? 0.6 times 2 squared divided by 2. Apa? 1.2. Apa unit kinetic energy?
Joule.
Good, Joel. Okay, good. All right, so next is we want to identify the work. Now, for this question, when you want to identify the work, the best is you need to draw the free body diagram lah. So draw the free body diagram. So first you draw the circle. Okay, so here at point O ni ada support. So kalau ada support mesti dia ada apa orang kata OY, mesti ada apa? OY, ada OX. Okay. Kenapa O? Sebab dia kat point O tu kan. And then you ada spring. So you ada force due to spring. Okay. Apa lagi you ada? You ada couple moment. You ada moment. And you also ada weight. Okay. Now, weight. So weight ni adalah actually 30 times 9.81 lah. So 30 times 9.81 berapa? Semua tekan calculator, tekan sendiri Make sure you're doing it 2, 9, 4.3 Newton. Okay. So these are the information you have. Oops, sorry. Radius berapa? 0.2 meter. Ni radius Okay. Okay. So now we need to identify what does work. Can you tell me what does work? Okay. Now, because the pin is taking moment dekat apa tu? We're taking moment dekat mana? Dekat dekat tengah ni, dekat node O ni. The weight does not do work because there's no displacement. So there's no work due to weight because kita take moment betul-betul. The weight, there's no displacement because it's at the center of the pin here. So the weight, so what we can say here, note, the weight does not do work. Okay. All right. And then why does the weak does not do work? Because class, because
Dia
there is
dekat
no there is no what? Displacement lah.
displacement.
Okay. There is no displacement. You need to understand that because dynamic can be easy if you understand the fundamental concept. Okay, you look at the question, you understand the fundamental concept carefully, you can able to solve it. Okay, all right. Now, so the couple movement apa is doing positive work. So couple. So what does work? So what does work? So we can say the couple movement. So the couple moment is doing is having it does have a magnitude. And what is the magnitude? 5 Newton meter kan? So we say the couple moment does work because it has a magnitude. So couple moment, the magnitude is what? 5 lah. Kan? Kalau tak letak 5 is M lah. M to 5 lah. Theta. Okay. Okay. And what else does work? Okay, and then okay, why does the couple moment does work? Because it rotates. The reason why? Because dia rotates. Kan the couple moment they rotate, so that's why it does work. What else? Other thing that does work? Class?
Spring.
Yes, the spring. So spring dia do negative work. Okay, alright. So the couple moment they rotate, they does positive work. And the spring and the formula for the spring, which is US untuk spring, dia adalah negative 1/2 KS squared. KS squared. This one does negative work. Okay. Alright, good. So you need to understand that. Okay. So since you dah understand that, then you can come up with the equation for work lah. So work one is due to the couple moment. Terus tulis lah kok. Terus tulis. Due to couple moment. And the other one is due to spring. Okay. So due to couple moment, M apa? M, what is the value for M, guys? Are you with me?
5.
Okay, 5.
5 Newton.
5. Okay. Theta ni apa? Theta ni lah the angle, the displacement yang kita nak cari, kan? The movement. Kan previously dalam topik apa tu? Particles, kita guna simbol S kan? So now theta lah. Okay. 1/2. And what is our K? Stiffness? 10 Okay. And what is our S? Okay. Now, do you remember S? S ialah lilitan kan? Kan? This is your S. This is your theta. And this is your R. So what should be S be? S equals to R theta. So R multiplied by theta kuasa 2. So now all dalam sebutan theta lah. Okay. The movement is the same. Okay. Is due to the angle kan sebab this apa spring dia kata dia wrap around the rim. So nanti dia ni lah. Okay, now. So then we have all the values. Can you please calculate? Can you please find theta for me? Put in the details, the equation. T1 plus work equals to T2. T1 is 0. Work is 5 theta minus 1/2 10 times R. What is our R? R adalah 0.2 theta. Jangan lupa ni kuasa 2 equals to 1.2 joule ni kan? Okay, find me theta. So basically your theta will be in a quadratic equation. Give me the smallest value of theta lah. Okay, and tell me what is the answer Okay, sekejap Dapat dah? So kalau you put it in a quadratic equation, what do you get? You will get negative 0.2 theta squared plus 5 theta minus 1.2 equals to 0. So what do you get for theta? Give me the smallest positive value. What do you get? Are you calculating using your calculator? Dah ke?
0.242.
0.2. 242. Okay. Betul. Tapi ni dalam unit radian. Dia nak angle. So what did I say? For radian to change to angle, you need to multiply by 180 divided by pi. Then you get your answer in angle. Can you give me your answer in angle? Dapat apa? 13.88.
13.88, yeah.
Okay. So that is the answer. So 13.9 lah. Degrees. Okay. All right. So okay. Now, good that you understand this. We need to do a few more questions related to rigid body for work energy so that you understand better. Are you okay? Can we proceed with another one? Okay tak? Okay kan? Takkan satu example je kot, kan? Kena at least 3-4 kot,
Doktor,
kan? Ya?
saya nak tanya macam mana nak tahu yang work tu positif atau negatif?
Okay. Moment ni dia memang in clockwise direction, dia moment due to memang positive work lah. Spring dari dulu I dah mention dah, dia memang negative work. Spring dia negative work sebab dia nak terpaksa return balik ke tempat asal, so dia negative. Nanti later on bila you buat topik vibration, you akan ada a lot of rotating, vibrating things, and because it needs to return back to its original position, dia ada banyak negatif lah. Spring memang negative work lah. Dia macam kalau you apa lagi positive negative work negative work contohnya you terpaksa angkat bag, letak naik atas the weight, itu negative work. Kalau you bag tu you letak ke bawah, itu positive work. Ada faham tak?
Maksudnya displacement dengan force tu punya macam ni, direction dia lah ikut.
Direction dia. It's in the because sekarang ni untuk soalan ni dia in the same direction, dia positif lah. Kalau dia in the negative direction, dia akan ada negative work lah. They're not in the same, the displacement is not in the same direction. Sekarang ni the moment ni kan dia bagi terus sebagai magnitude kan. Lagi satu the direction of the moment and the angle is the same. So dia positive work lah. Dia macam ingat tak dulu saya ajar kalau the workforce is not in the same direction of the displacement, dia jadi negative work lah.
Okay.
Okay.
Okay, faham. Terima kasih,
Yelah,
Doktor.
I faham sebab you are worried that the question can be easy but due to careless mistake, positive, negative, you boleh dapat salah, tak dapat jawapan, tak dapat markah penuh kan? Betul-betul. So that's why we need to practice lah. Good, good. Okay. I'm hoping that this semester zero failure for dynamic I am really hoping everybody pass no failures at all from this class langsung tak ada I want you to really do well so I'll be open for anyone to ask questions and we have provided that revision kit. I want you to do it it's going to help you for your test but the most important thing is you understand if you have like 10, 20 solutions for the final in front of you but when you get the question you don't know where to start, which one to follow pun tak boleh juga. So it's best that you do the exercise, the revision kit, you understand by heart, bukannya macam buat semata-mata nak ada kat depan mata supaya bila test tinggal meniru je. Tak. It's not going to work like that. It's better you do it and understand it so when you get a question for your test, you can do it by yourself. Faham tak? You know what to do. Itu yang kita nak. Okay? Dynamic bukan ada the way of studying bukan solution depan mata and then you tengok yang mana yang paling hampir you tiru. Tak ada. Itu salah teknik. Okay? Okay, copy this question and tell me when you've done lah.
Dah.
Okay, dah.
Dah.
Okay. All right. The wheel shown weighs 20 kilograms and has a radius of gyration K 0.2 meter about its mass center G. If it's subjected to a clockwise couple moment of 25 Newton meter and rolls from rest without slipping, determine its angular velocity. So for this question, what they ask you to find is determine its angular velocity. Maksudnya dia nak omega lah. After its center G moves 18 meters. So center G ni moves 18 meters. The spring has a stiffness K and initially unstretched when the couple moment is applied. Okay, so for this question, number one, step pertama, tulislah formula. Dapat markah. Okay. Now, for T1, can you guess what is T1?
Zero.
Yes.
Zero.
So T2, let's do T2. So what is T2? So T2, of course, formula dia ialah 1 over 2 I omega. Now, because they rotate kan, dia hanya rotate. So due to rotate, dia 1 over 2 I omega. Lepas tu, now, because remember, I ada tulis note ke atas ni, because they rotate about a fixed axis, okay, and then they rotate, dia bergerak, betul tak? Dia ada pergerakan, class, you remember, they rotate about apa? A fixed axis. The formula untuk T tu kita boleh buat IG plus MR squared, omega squared. So tulis balik formula tu. Mana tadi? One over two. Mana formula tadi? Apa? I G plus MR squared tutup kurungan omega. Okay. So 1 over 2. Okay, what is the I? Now for this I, you nak pakai I apa? Ada dua jenis I for this kan? Is it 1 over 2 MR squared or MK squared?
MK squared.
Right, because dia bagi tahu ni. You akan dapat markah untuk tu. Make sure you buat. So MK squared plus MR squared Alright. So tulis. So mass kita tahu 20 kan 20 oh 20 ini 20. The mass is 20 and the K radius of gyration is 0.2. So the mass 20 and the R is 0.25 squared omega. So can you tell me what you get? Jawapan dalam omega? What do you get? What do you get? Hah? Ke saya kena kira? 20 kali 0.2
1.025.
1.025 omega squared. Okay. Now, let's draw the free body diagram so that we can understand what is the work involved. Ahmad batuk. Okay. So, dia dekat atas platform ni. Oops. Okay, so akan ada weight ni. Oh. Azim. Ambil air untuk Ahmad. Okay, so you have the weight and then you have the spring force and then sebab ni atas platform ni you have the normal force. Okay, sini saya namakan B ya. So ini point A ke atas ni kan. A ke atas ni. Okay, ada apa lagi? Oh, and then you ada couple moment tu. 5. Okay, so now let's write down what is the weight work involved. So now, what do you think the work involved? Okay, if you can look here, the only thing that is doing work is the moment and the spring. The weight is again is not displaced down, so there is no work due to weight again. So it's only the moment of the couple moment and the spring. Okay. All right. So again, moment and the spring. Okay. So the moment kat sini adalah 25. Okay, what is the theta? Now, dekat sini dia bagi tahu kan? Dalam question dia bagi tahu dia bergerak how much? Angular velocity after eccentric G moves 0.18 meter. So dia ada move 0.18 meter. So kita tahu S dia adalah 0.18 meter. So kita tahu S sama dengan R theta. If kita nak theta, kita kena S divided by R lah. S kita ialah 0.18. Kita punya radius. Radius 0.25. So radius kita 0.25. So what is it? 0.18 divided by 0.25. Divided by 0.25. 0.72 radian. Okay, so this one 0.72 radian lah. Okay, and then minus 1.2 K. K kita adalah 150. Okay, S pula. Okay, S adalah R theta. Okay, now kita punya theta ni adalah berapa tadi? 0.72. Okay, R dia for it to go from point A to B from satu loop ni, dia R dia you kena ambil 0.25 kali 2. So dia jadi 0.5. Okay. So kat sini dia punya S ni adalah kira kalau kita kira 2.5 0.5 times 0.72 0.36. Okay, so ini 0.36 square lah. Okay, so tolong kira dapat berapa ni? 25 kali 0.72 minus 100.5 bagi 2 kali 0.36 square. Dapat 8.28. Okay, so basically just put in the formula. Formula tadi apa? T1 plus work T2. So T1 ialah 0 plus 8 point point. Yeah. Okay. Can you tell me what is the answer for omega? Apa-apa?
.842.
2.8 4.
Lah, ada square length.
Okay. Apa saya tekan? So omega sama 2.84. Okay. Betul? 2.84. Apa unit dia? Radian per second. Okay, good.
Second.
Okay. Alright, good. Good that you have done that. Okay, another few more, another example. Okay, I want you to copy this this other example lah. Okay, good. So you got that. Okay, alright. Okay. Okay, let's try 2 more examples. Okay, this example, I just want you to copy, and this is the diagram. However, okay, tolong copy. Dah?
Dah.
Ni gambar dia. Ni gambar forklift Tahu tak forklift dekat lab tu? Boleh bayangkan tak yang macam yang apa jentera macam yang dekat lab tu yang angkat-angkat barang tu. Yang selalunya warna kuning ke oren. Allah. Apalah macam tu. Saja color-color antara. Dah? Okay. Okay, now. Okay, so untuk you solve problem ni, okay, let me just read it to you. The 100 kg pipe is equally suspended from 2 tines of the forklift. Okay, so ada forklift ni lah. Suspended from 2 tines ni lah. Forklift lah. Okay. It is undergoing a swinging motion such that when theta equals to 30 degrees, it is momentarily at rest. Determine the normal force acting on each tine which are needed to support the pipe at an instant of theta equals to 0. Measurement of the pipe and the measure of the pipe and the suspender are shown. Neglect the mass of the suspender and thickness of the pipe. So for this question, what it wants you to do is calculate the normal force determine the normal force acting on each tine. Apa soalnya? Swing motion. Determine the normal forces. So the normal forces. So ada lebih lah. So bila dia kata normal forces, so kalau based on this diagram, the normal forces adalah apa N dengan F lah. Okay. So sebelum tu kita kena draw lah free body diagram dia betul-betul lah. Let me draw the free body diagram for you. Okay, give you ni. Okay, the questions that we are doing is actually difficult lah juga. But however, you will not get a difficult question during the test kot. You'll be fine kot. Besarnya saya buat ni. Lah. Okay, let's draw the free body diagram. So, ni point O ni kat sini. Point G dia kat sini. Okay. And boleh tak boleh? Oh, ada ruler. Okay, menarik. Supaya drawing cantik sikit. You guys okay tak apa. I believe kalau you all buat yang revision kit tu, you all boleh faham dan score. Okay. Alright. And then, okay, the free body diagram is important. Oops. Okay. 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 All right. So this is the angle. Okay. So this is the angle. Okay. That's point G. So the weight. Okay. And panjang ni 0.4 meter. And okay. So this is the normal force. Let's say normal force times the normal force of the times NT. And this is the FT lah. Satu NT, satu FT. Okay. So, alright. Okay. So, alright. So, number one, what we need to do is we know that kita akan pakai formula ni lah. T1 plus work equals to T2. Now, for this question, because the pipe is originally at rest, so apa jadi kat T1? 0. Okay guys? Okay kan? Now, T2. Macam mana kita nak calculate T2? Okay. Ada dua method cara kita nak calculate T2. Now, kita nak calculate T2 ni sama ada kita nak take moment kita can take either the reference fix at point O or the center mass at G. So ada dua cara. Okay. So if kalau kita nak ambil center mass at point G, ada dua cara. So let's say at point G. At point G, kita akan pakai formula ni lah. 1/2 mv squared. Okay. Plus 1/2 I omega squared. Okay. Now, alright. Ini kalau kita take at point G dulu So kalau kita take at point G, dia akan jadi 1/2. What is the mass? 700 Now, what is the V? Velocity. Do we have the V? Now, ingat tak formula V? V sama dengan apa? Ingat tak formula? V sama dengan R?
Omega.
Okay, ingat. Okay, V sama dengan R omega. So, what is our R?
0.15.
Hmm. Dia punya R ni apa? Um, Kejap macam difficult pula kalau kalau ambil kat point O nampak lagi senang. Kejap Just give me a second nak memahamkan dia punya ni je. I rasa kita pakai yang cara tadi tu nampak lebih mudah. Yang kita baru belajar tadi tu. Biar konsisten kot. Sekejap. Kakak you all confused nanti. Nak buat ni. Okay. Sorry Tak apa. Okay. So kalau kita take at point O tadi. Ingat tak bila kita take at point O. Kita punya formula adalah 1/2 I omega squared. And then I dia adalah formula dia apa tu tadi? Mana yang tadi tu? Formula dia adalah M R squared plus M. Ingat tak? D squared. Sebab ni rod kan? So M kita apa? Kita punya mass 700. And then kita punya R adalah 0.15. Okay. And then sebab kita nak take dekat point O, so kita punya mass ni 700. Okay. And then kita punya D tu adalah panjang ni daripada point G ni ke point O. So D kita adalah 0.4. And then kita multiply by omega squared. Okay. So untuk yang ini kita tak ada value omega lah. So kalau you calculate ni, you akan dapat jawapan dalam omega squared. Apa? 100 0.15 kuasa 2 plus 700 kali 0.4 kuasa 2 divided by dapat berapa? Enam tiga. 63.
3.88.
Okay, 63.88 omega square. Okay, so itu kita dah settle. So basically, and then kita kena work involved lah. Okay, so sekarang ni what is the work involved? Work ialah T1 plus work equals to T2. So T1 adalah kosong. Okay, work. Okay, now work yang berlaku kat sini, apa work yang involved dalam gambar rajah yang you nampak ni? Based on diagram. Yes, work due to weight. Why? Because ada displacement kan? Displacement dia yang mana? You boleh bayangkan tak? Cuba you pegang you all punya pen macam ni dan dia ni pusing. Displacement dia bergerak mana displacement dia? So daripada gambar ni sebenarnya displacementnya adalah ni. Yang ni. Ni. Nampak tak dalam gambar ni? Ni adalah displacement dia. Okay, so dia tu weight. Okay, kenapa yang ni tak ada apa? Kenapa FT dengan NT ni tak ada work? Kenapa? Sebab kenapa? Kenapa normal dengan frictional force ni does not do work? Kenapa
Tak
this
bergerak.
one? Why it does not do work? Because it does not swing lah, kan? And does not move lah. Does not swing means not moving lah. So the only thing that is moving is the weight here. So untuk sini, so bila you nak buat work due to weight, you akan buat formula dia apa? Work due to weight. Ingat tak formula dia? Delta W delta W pula. Negative W delta Y. So negative W adalah mg lah. Betul tak? Negative mg and then delta Y. Okay, now sekarang ni the weight does positive work ke does negative work? You rasa?
Positif.
Kenapa positif? Kenapa it does positive work? Sekejap, can you give me 2 minutes tak? Sekejap. Hello? Okay. Tadi, okay, it does positive work. Betul. The weight does positive work because it moves downwards. Betul tak? Dia move downwards. Sebab itu dia does positive work. So, apa kita punya delta Y? Delta Y kita berapa? Macam mana kita nak kira delta Y? Macam mana you nak dapatkan delta Y tu? Boleh kira tak? Soalan ni memang mencabar tapi bagus sebagai exercise 0.4 adalah dia punya ni kan. Dia delta Y adalah Y2 minus Y1 lah. So let's say dia punya ni adalah Y2 adalah okay, so delta Y adalah 0.4 minus berapa? Okay. Macam mana kita nak dapatkan value yang kecil tu? Macam mana? Angle dia berapa? Dia bagi tak angle? Dia bagi kan? Angle adalah 30 kan? So macam mana? Macam ni nak dapatkan ni? 0.4 berapa? Berapa kau? Alhamdulillah. Alhamdulillah. Hello? Kesalan. Tengah kelas. Kenapa? Ada boleh call chat lagi? Kejap je. Boleh? Ada? Boleh? Okay. Alright, salam. Okay. Kejap ada orang pula minta nombor phone. Okay, cuba bagi tahu saya macam mana nak dapatkan height tu. You all conteng-conteng ke kertas tu? So, delta Y ni adalah 0.4 ni minus 0.4 sebab you nak dapatkan tinggi tu cos 30 degree lah. Okay. So, in the end 0.4 minus 0.4 cos ni berapa? Ini simple maths je. You akan dapat 0.053. 535. Oh, 9 meter. Okay. So nanti bila kita nak letak dalam formula work ni, so M 700. Okay. 700 kali 9.81 kali dengan panjang tu, sebab kita dah tahu positive work, kita suruh buat dia positif lah. Okay. Equals to T2. T2 tadi berapa? 63.88 omega square. So daripada sini kita nak dapatkan omega. Okay. You all kena bayangkan macam mana nak dapatkan tu, sebab dia punya movement tu macam ni. Dia move due to the angle 30 degree dan dia punya pergerakan daripada tinggi tu ke bawah tu. Macam mana dia punya movement 30 tu. Okay. Okay, you kalau tak boleh bayangkan, you need to ambil a pen, pegang and imagine. Okay. Alright. So daripada sini kita akan dapat omega. Okay. Alright. Now, soalan dia minta kita dapatkan normal force ni. Tapi kenapa kita kena dapatkan omega semua ni? Sebab nanti kita nak masukkan dalam formula Newton second law lah untuk solvekan normal force tu. So omega square you dapat apa? Dapat 2.4. Betul tak? Okay.
Betul.
Dapat sama tak? Okay. Alright. Okay. So now since kita nak normal force, kita kena guna formula ni lah. Kalau you all ingat. MAGT. Ingat tak formula ni? Okay. Right. Tak apa kelas. Video ni recorded and then you boleh tengok balik. Kalau you tak faham, you kena tanya. Macam tu lah. Ingat tak formula ni kita ada belajar itu? Okay. So untuk kita ada direction in T dengan normal. In T direction, tengok balik diagram, in T direction you akan ada apa? In T direction you akan ada FT equals to, so you akan dapat force FT equals to M dia 700 and then A lah, AGT. Now in the normal force diagram you ada apa? In normal, in vertical lah, in vertical direction you ada apa? You ada normal force, then you ada apa lagi?
W.
Okay, ada W. So the normal force tu, let's say atas positif, so you ada normal force, and T, normal force, ni T Oops, sorry. And then you kata ada W. So W tu akan jadi negatif W. W adalah 700 kali 9.81 teruslah equals to mass 700 and then kali AG. Okay. AGN. Okay, kita ada AGN tak? Ingat tak formula AGN? Formula AGN apa? Ingat tak? V? Ingat tak? Ingat tak formula ni? Kelas, ingat tak formula ni?
Ingat.
So? Okay. Yang gaduh. Okay. So macam mana? Macam mana nak dapatkan AGN tu? So kita ada omega. So AGN ni juga sama dengan velocity ni sama juga dengan omega. Sebab ni velocity. So kalau dalam rigid body, velocity sama dengan angular velocity. So Macam mana guys? Boleh tak? Are you lost? AG macam mana? 700 kali apa? Ya. Kelas, macam mana kelas? Ingat tak?
AN ada formula R omega kuasa 2.
Itulah yang saya nak. Betul? Ni tak nak ni. Tak nak ni. Sorry. I dah lupa dah kot. I lupa pula. AN sama dengan apa tadi?
R omega kuasa 2.
R omega kuasa 2. Okay. Itu lagi senang. So, AN sama dengan R omega kuasa 2. Sebab kita nak pakai yang ada omega kan? Betul lah. You all ni I yang blur pula dah. Sorry. I baru lepas apa ni. Adalah dia. Lepas minat kan. Okay. So, R sama dengan 0.4. Omega tadi kita dah dapat berapa? Mana? 2.4.
2.4.
Tapi ni ada kuasa 2 kan? Dekat 2.4 tu ada kuasa 2. Okay. Alright. Lepas tu take moment. So you take moment dekat point O ni. So dia sama dengan kosong equals to I macam mana nak calculate I? Tadi kita dah calculate I kan? Tadi I tadi. Macam mana I tadi kita calculate ni? 700 kali 0.15 kuasa 2 apa tadi? 700 tambah 700 kali berapa tadi? 0.4. Ingat tak tadi I kita calculate I?
Ingat.
Kuasa 2. So ni I kita yang kita calculate tadi. Tapi kita kena calculate multiply dengan ni apa? Alpha. Okay. Alright. Lepas tu ada formula apa ni? Yang ni tertinggal ni. Formula AGT ni. AN sama dengan R omega squared. AT apa formula tu?
R alpha.
R alpha. So tadi kita tertinggal. Formula AT sama dengan R alpha. Okay. So AT sama dengan R alpha. Okay. So alpha, value alpha berapa? You rasa alpha sama dengan apa? Kenapa alpha sama dengan kosong? Siapa boleh bagi tahu I alpha? Kenapa sama dengan kosong? Kenapa alpha angular acceleration ni sama dengan kosong? Siapa boleh bagi tahu I? Kenapa angular acceleration dia kosong? Cuba tengok ni AT, AN. AT dengan AN. Satu direction AT, satu direction AN. Yang ada pergerakan direction AN ke AT? Kelas? Kalau based on this diagram, yang ada pergerakan arah direction AN ke AT?
AT.
AT ke AN?
AN.
Kan? Dia arah AN kan? So that's why angular acceleration ni kosong. So you can say that AT sama dengan kosong. So bila AT sama dengan kosong, bila ni jadi kosong, apa jadi kat you punya normal force? F. Mama.
Kosong.
Kosong juga Sekejap sorry kita kat rumah ni budak cuti sekolah banyak sangat gangguan. Okay, so FT sama dengan kosong. Okay, good. So next NT sama dengan berapa? Tolong kirakan. Dapat apa? Tahu kan tadi kenapa angular acceleration sama dengan kosong? Sebab kita punya apa tu forklift tu dia turun naik arah normal force direction saja, dia tak pergi ke kiri ke kanan. So that's why our angular acceleration kosong. Okay? Benda ni bagus untuk praktis sebab kadang-kadang ni untuk project you sesuai lah nanti. Topik project untuk understand. So apa normal force? Ni. Dah kira dah?
Saya dapat 8479.8.
Okay, so kalau dalam Newton, kilonewton 8.48 lah kilonewton ni Newton. Okay, now so ni the normal force yang dia carry, tapi sebab benda ni kalau dalam soalan ni dia bagi tahu ada two times. So maksudnya forklift tu dia ada dua yang memegang dia. So normal force ni kena bahagi dua lagi. So kalau dia nak normal force untuk satu, 8.48 kena bahagi 2. So kalau bahagi 2 dapat 4.24 Newton. Okay. Alright. So kena bahagi 2. Okay. It's okay. Mencabar soalan ni tapi bagus sebagai exercise supaya kalau you dapat soalan yang lebih susah atau lebih senang, sebenarnya lebih senang, you patutnya boleh buat lah. Tapi at least ada exposure tu. Okay. So kita kembali balik ke apa yang kita belajar dari tadi. Okay. So kita recap apa yang kita belajar hari ni. Okay, tak apa, ada banyak exercise yang dalam revision kit yang kita orang dah bagi dengan solution, steps yang you boleh buat. So untuk rigid body ni, kita tahu kita akan guna principle of work and energy. Yang penting sekarang ni macam mana you nak identify apa formula kinetic energy yang you nak pakai dan macam mana you nak menggunakan dia. And then yang kedua, you must identify apa work force yang involved. And then a new thing is that you ada couple moment. Okay. Jangan stres mungkin you rasa susah hati sikit sebab dah lama tinggalkan subjek dynamic ni, tapi dia tak susah. Okay, you punya test saya rasa senang untuk semester ni. So I'm sure you boleh score. So ini satu first example kita buat. Untuk example ni dia minta angle. Okay, tapi menggunakan work energy. Untuk example seterusnya pula dia minta angular velocity, dia minta omega pula. Tapi konsep dan cara sama. Okay, yang ni pula dia minta angular velocity pula. Dan yang last kali ni lain sikit, dia minta normal force dengan frictional force. Dekat times ni, dekat point O ni. So mungkin soalan ni lebih susah sebab you nak imagine kan, dia bagi you diagram macam ni, tapi from this diagram macam mana you nak dapatkan diagram yang complicated ni lah. You ada normal force NT, you ada FT, and then you ada G kat sini, and then angle, and then you kena identify formula kinetic energy mana you nak pakai. Lepas you dah identify kinetic energy, apa formula work you nak identify. Tapi proses ni sebenarnya datang, kenapa you kena buat ni, sebab you nak gunakan ni untuk dapatkan AG. Ni. Bila you nak, kenapa you nak dapatkan AG, sebab you normal acceleration ni, AN ni formula dia. I pun dah terlupa formula ni. Okay. So ni lah formula dia. That's why dari awal ni you dapatkan omega. Okay. Alright. So in the end sebenarnya inilah motifnya. So class, so you all untuk dapatkan normal force ni, kita pakai yang formula normal and acceleration ni lah. Normal acceleration pula. Normal and apa tadi? Tangential. Okay. Saya nak pesan untuk you punya upcoming test ke apa, bila you buat jalan kerja, you tulis ni je you dapat markah 1. You tulis ni je you dapat markah. You tulis ni je you dapat markah. Okay. Kalau boleh make sure you tulis equation of motion tu. Okay. Then you buat ni you dapat markah. Macam ni dapat markah. Macam ni dapat markah. Selalu saya perasan student dia banyak tertinggal bila dia nak buat jalan kerja yang part-part yang macam ni. Jangan tinggal. Ni semua you akan dapat markah tau. Begitu dengan yang ni. Yang ini kan you tulis formula principle of work, utility sama kosong, you tulis formula ni balik, semua ni akan dapat markah. So make sure you jangan tertinggal lah. Okay? Alright. Okay. Boleh tak guys? Ada soalan tak? Sebab masa dah dekat pukul 1.
Doktor, saya nak tanya untuk yang example kedua tadi. Yang untuk spring punya S tu, kenapa dia punya R 0.5 R kan 0.25.
Oh ni. Spring ni. Kenapa R? Sebab dia rotate, dia pusing. Kita kena consider one rotation. One circular rotation. Untuk spring punya S, one circular rotation adalah one circular rotation kita kena ambil dia punya diameter lah. Kita akan consider as for one. Okay? Okay. Lepas tu tadi ini tak ada diagram apa tu? You kena lukis diagram ni tertinggal. Apa tu? Diagram AT dengan AN. Kan bila you buat kinetic energy kan you kena ada diagram tu. Okay. Diagram apa yang kata? Ni. Last dia. Apa orang kata? Free body diagram and kinetic diagram. Kalau you draw the free body diagram and kinetic diagram, mungkin you akan nampak. Okay, cuba kita draw. Assume dia dalam keadaan macam ni lah, tak berpusing. Macam ni. Okay. So, ini FT. FT pula. FT ini NT. Okay, and then you ada weight, betul tak? Okay. Ini free body diagram you untuk untuk yang gambar tadi lah. Lepas tu kalau kinetic diagram macam mana? Ingat tak? You ada apa?
MA.
MA apa? T, lagi satu? MA N.
N dengan MAT.
Jangan tinggal. And then jangan lupa, ni pun dapat markah tau. Sebab dia rotate. You lukis, dia gambar rajah ni sangatlah penting untuk dynamic. Sebab you akan dapat markah. Make sure you draw. Okay? So you akan ada MAT dengan MAN. So ni diagram dia lah. Panjang ni. You tahulah. 1.4 meter tadi kan? Okay, so make sure you draw the diagram.
Dia memang ke atas ke medium?
Apa dia?
MAN dia memang ke atas
MAN. Dia MAT kat sini, MAN kat sini. Dia macam ni. Ingat tak macam mana nak draw MAT, MAN? Let's say you punya macam ni. Kalau ni adalah you punya pergerakan dia ke sini, contohnya velocity dia ke sini. Ini dia bentuk bulat dia punya cara dia rotate. Ini adalah AT, ini adalah AN. Ingat tak? So anggaplah ini you punya forklift tu kan, dia boleh, benda ni kan dia boleh rotate dan cara dia sway macam mana? Macam ni kan? So assume lah, let's say this is your ini adalah T, and you macam mana? Betul tak? Betul tak guys? Salah ke betul?
Betul.
Direction tu. So N ke atas, bukan ke bawah Okay? Sebab dia sway macam ni kan, dia sway. Dia sway Macam tu lah. Display macam tu. Something like that lah. Tapi tak apa. Soalan ni mencabar dan bagus untuk you buat dan praktis, okay. Dan yang penting sekarang ni, apa yang I nak you buat ialah you ambil masa untuk buat revision kit ni. Nampak? Ada solution dah. Ada solution dengan jawapan akhir. So boleh cubalah. Yang mana yang topik yang dah berkaitan yang kita dah go through, you dah boleh mula buat dah. Dan you boleh try. So kalau boleh, saya rasa kalau you all dapat completekan revision kit ni sebelum test, you can do the final exam lah very well lah. Saya akan share ni kejap lagi. Saya buat dalam album, saya share, saya bagi. Termasuk projek. Nanti saya bagi announcement. Alright? Okay. Jangan risau. Saya memang kalau ada soalan, tanya je lah. Okay. So itu je lah untuk kelas today. Alright. Saya stop recording.